Welcome to Sanjeev Jagia and Allison Kelly, our esteemed authors of the ever popular Business Statistics Communicating with Numbers, 4th edition, as well as Business Analytics Communicating with Numbers. They're going to focus today on the evolution of business statistics and bringing analytics into the existing BStat course. So Allison, take it away.
Thanks, Harper. And thanks to all of you out there who have decided to spend your time with us today at this session. Sanjeev and I would like to focus on some trends that we have seen emerging in teaching business statistics, say over the past 5 to 10 years. Even though we've been teaching it for longer than that, we're gonna just stick with this time period. And specifically what we wanna look at is how we now have this linkage with business statistics and business analytics. And then in addition to that, we want to talk about how we can incorporate some of the suggestions from the American Statistical Association's guidelines, most recent guidelines, how we can incorporate those suggestions into both our text and our teaching. So what I first want to focus on is the linkage between business statistics and business analytics and what we've seen happening in the real world. And what we've seen is we have just an abundance of data and an improved technology that's allowing businesses to make decisions in a different way. And what we're seeing, at least from the demand aspect and what employers want, are graduates that have some knowledge of how to prepare data, estimate models, and then more than that, then interpret these models, take off the technical hat and put on the non-technical hat. So to drive these insights into actionable decisions. And we use there's no universal definition for business analytics, but we've adopted the one from Informs, and that is to just transform data into insights for the purpose of making better decisions. So with all this growth in business analytics, we feel as educators, we need to teach now business statistics with this analytics mindset. In addition to that, what we've seen, the latest GEIS report, and this is, if you are not familiar with it, it's published by the American Statistical Association, and its guidelines for the assessment and instruction of statistics education. They've set forth a number of suggestions as to how our teaching should be evolving, given what's happened with technology and data. And two of the main suggestions, at least that we've taken away, is that students should be able to interpret and draw conclusions from standard output from statistical software, and instructors should consider shifting away from the use of tables. So those are two main suggestions that the American Statistical Association is expecting of us educators in our pedagogy. So we feel that in a nutshell here, we should be using technology for computations and then focus on data for these insights and action. So when we were writing the 4th edition of our textbook, we tried to incorporate both what we were seeing in business analytics as well as the suggestions from the American Statistical Association. So we've made 4 innovations. I'm going to go into a little bit more depth as, once I explain these innovations. So let's start. The first 2, I would say, are more in tune with what's happening in the business analytics world. So we always see descriptive statistics in traditional statistics textbooks, but what we've decided to do is we've decided to place a lot more emphasis on data preparation as well as visualization. The predictive branch of business analytics, we've done a significant rewrite of regression as well as forecasting. And now, in terms of the Geist report, we're putting more reliance on statistical software as well as Connect. And finally, storytelling. We've always felt, as you might see from our subheading on our title, that communicating with data has always been important, but we're even making it more relevant in our 4th edition. So what have we done in terms of data preparation and visualization? Well, right from the start, we devote some time now to data preparation, something that I would call this baby data wrangling. We don't go into as much depth as we do in our other textbook, but we feel that students need to have some exposure to looking at raw data and making some interpretations with that, making some preliminary insights into data preparation. We have devoted more updated, I would say, data visualization methods in Chapter 2. Again, I'll talk about that shortly. We talk about now subsetted needs in Chapter 3. And finally, we use pivot tables to analyze empirical probabilities in Chapter 4. So what do we do in Chapter 1? Well, this is an example from the textbook where we have a company that matches employees with short-term engagements. We have 604 observations, and in this chapter, we're just trying to let students get a feel for what they should be doing with raw data, maybe understanding how many missing observations they have. What should they be doing with those missing observations? Maybe answering some questions for the company, like how many of these employees worked in the automotive industry? How many earned more than $30 an hour? How many worked in the automotive industry and earned more than $30 an hour? We just use simple counting and sorting rules in Excel to show students how to get a preliminary understanding of the data. And we feel that then helps them later on in the course when we all get those questions. I didn't know what equation to use. Well, many times they just don't know what kind of data they're actually dealing with. In Chapter 2, we have more data visualization methods. And again, we feel that they're the most widely used in business analytics. So we typically, in this particular example in Chapter 2, we're looking at an e-retailer who is sending an online retailer who's sending promotional discounts through emails to customers. And had we just looked at a bar chart, we would see that most of the emails went to the Midwest, less went to the West, if we're looking at location. But what the stacked column chart shows us is that more people from the South actually responded to the promotion. Far fewer in the Midwest actually responded to the promotion. So again, we see this hidden information once we start diving a little bit deeper into these data visualization methods. In the same vein here, most of us show a scatter plot. And here I show price against square footage for houses. But we might want to know, okay, what kind of relationship do we see? Is it any different if I look at a single family dwelling versus a condominium, right? So we've just added a little bit more to what we typically see in a traditional statistics textbook. And a really useful tool that we introduce in Chapter 3 is what we call a subsetted mean. And here I have an analyst that's looking at past data on spending trends in clothing, health, technology, and the miscellaneous sectors. And all of us teach how to calculate means, so we could get the means spent on clothing, mean spent on health, mean technology, mean miscellaneous, but it wouldn't help us in terms of targeting our advertising expenditures to different segments of the population. In this case, we have divided the population male, female. So when we calculate subsetted means, we find that females spend more on clothing and miscellaneous as compared to males. Males spend more on technology as compared to females, and males and females spend about the same on health. So this is information in terms of targeting advertising expenditures that we wouldn't have been able to talk about had we not calculated these subsetted means. And one of the last thing I want to talk about in terms of descriptive statistics is our use of pivot tables in Chapter 4. And we feel that this really lends itself to a more holistic approach to calculating empirical probabilities. So most of us, I know I was one of these instructors. When I started talking about probability, I just started with the contingency table and talked about what a contingency table was. But now what we want the students to do is to actually construct the contingency table from this raw data so that they would understand that they're dealing with two categorical variables. And here we're looking at a fitness, a gym, and looking at whether potential clients, how old they are, what age range they are in, and whether or not they enroll in the gym. So once we learn about creating a pivot table, here's our contingency table. So they've taken the raw data, they've converted it into a contingency table, and now they can calculate probabilities. I mentioned too, we've done a significant rewrite of regression and forecasting. So we've streamlined our discussion of goodness of fit measures. We've revised the section on model assumptions and common violations in Chapter 15. We've improved visualizations to explore nonlinear models in Chapter 16 through 18. We have a new subsection on accuracy rates for binary choice models in Chapter 17. And we have separate sections devoted to linear and nonlinear forecasting models in Chapter 18. So I want to focus here on how we've addressed the model assumptions for the classical linear regression model, or OLS, ordinary least squares. What we typically see, and what we did as well, was we tend to just list the assumptions, maybe explain what they mean. But again, we felt kind of like the pivot table, that it wasn't a holistic way of addressing the assumptions of the classical linear regression model. So now we state the model, but now use graphs. Again, these visualizations to see when this assumption might be violated. So in this particular figure, this easy, and we try to simplify it, stick with residual plots, not more advanced testing procedures to detect violations. Here we see a U shape in the residuals against age, which is not a good thing. That's actually a violation of the assumptions. But we see it now visually, and then we provide a remedy. So we see the assumption, we see how to detect a violation of the assumption, and then we provide a remedy. When we get to nonlinear models in Chapter 16 through 18, we plot the relationship between X and Y, and we see whether a linear model best describes the data or a nonlinear model. Here, possibly a logarithmic model or a quadratic. We do the same with forecasting. In this case, we show just how smoothing gets rid of the jagged edges of the actual raw data. And finally, in the we show how to use or how to calculate an accuracy rate in a binary choice model. What we had done in the past was that we looked at the linear probability model and the logit model, but then we didn't explain how you would decide over which model might be best. And here we show that you can use the accuracy rate to choose between different binary choice models. And as I mentioned, the last thing in this innovation too is we have separated linear regression models for trend and seasonality for nonlinear regression models for trend and seasonality. Understanding that some instructors might just want to do linear, might just want to focus on the linear regression models for forecasting rather than go into the nonlinear regression models. So with that, I'm going to let Sanjeev take over and discuss our last two innovations.
Thank you, Alison. I'm Sanjeev Jagia, and I'm the second author on business statistics, and I'm also one of the authors on business analytics. I know some of you might have watched the previous presentation as well. So as Alison said earlier in her presentation, that the explosion of the field of business analytics is partly explained by the availability of data and improved technology. Maybe I'm telling my age, but I remember when I was working on my research papers, a sample of 100 was considered pretty big. Now, when you have so much data, sometimes you have to figure out how to take a portion of the data for the analysis, because otherwise there's just way too much going on. And the same thing with technology. I remember, estimating some of these more complex models was so difficult. You really needed to know a lot more coding than you do now. Now, even though we have these programs like R and Python, but I mean, most of the formulas are already there and the libraries are already there. You're just using them. And Alison also pointed out about Guy's report, where the emphasis, according to American Statistical Association, should be to interpret computer output and whenever possible, stay away from tables. And those are the kind of things that lead us to come up with this innovation. So greater use of Excel and R in solving problems. I'll do some examples with that. And expanded R instructions in all chapters and forecasting chapters, regression and forecasting chapters. And then take all those instructions even into Connect, and which we think makes a better Connect product. Next slide, please. So this is just an example where we are now using technology. By technology here, I mean Excel and R to solve problems. And once we do that, we have a little bit more time to really fully understand what the question is all about, to understand these distributions more intuitively, because once we've got that, solving a problem in Excel and R is really not that difficult. So take a look at this example. This is about Facebook. According to a recent survey, 68% of all US adults are Facebook users. And you're taking a sample of 100 randomly selected American adults. So the questions are, what is the probability that exactly 70 American adults are Facebook users, or more than 70, or at least 70? I mean, those are the three questions. So now we can emphasize the distribution that is relevant to solve this question. So here is obviously a binomial distribution. And then not only that, we can also now have more time to emphasize creating the right probability statements. So when it's saying, what's the probability that exactly 70 American adults are Facebook users, we want students to know, first of all, it's a binomial distribution. And secondly, we are finding probability of X equal to 70. Whereas in B, its probability of X greater than 70. We know that P, probability of success here, is 0.68. We also know that the sample size is 100. Now we can go back to the binomial formula and say 100 factorial over 70 factorial over 30 factorial. We can do all those things, but we are not sure, what purpose is that serving. We do explain that in the book where the formula is coming from, and we even do an example where the formula is used. But a problem like that, you can see that now we can very easily estimate these things using Excel. And when we are solving with Excel or with R, as you can see from the slide, we provide quite a bit of detail. It's not just saying, just do this in Excel and get the answer. We are not serving them fish. We are teaching them how to fish. So there is a little bit of, this is the formula. The formula is binom dist in Excel. But then we are explaining all the inputs that go into the formula. What is X, what is N, what is P? Once they've got that, then solving this is really not that difficult. And if you look at R, it's exactly the same thing. We are introducing them to D binom and P binom functions, and then we explain the inputs. And once you put in the inputs, there comes the answer. And the two answers are the same. I just want to say one thing that McGraw-Hill has a great Connect product that many of you might be using. And we used to, I used to say that my hair would be a lot darker if we didn't have to come up with all those tolerance limits in Connect. Because when you're using the formula, somebody is rounding to 2 decimal point digits, some is rounding to 4 decimal digits. They're getting it right, but they're not getting the exact answer that you have in Connect. So we did put in the tolerances, and which worked, but it was never satisfactory. And now that we are using computers, there is no issue. We still use tolerance in case somebody wants to use the formula, but that really helps us. Next slide, please. This is another example, but this time it's normal distribution. So Akiko has a restaurant where she buys salmon, and she believes that the average consumption of salmon is 12 pounds and the standard deviation is 3.2 pounds. And again, it's a difficult question for every person. How much salmon should I buy? I should buy enough that I meet consumer demand. At the same time, I don't want to buy too much, but in order to make sushi, everything has to be fresh. So it's like, again, students know that it's a normal distribution, and the questions are, what's the probability that the demand for salmon is above 20 pounds, or what's the probability is less than 15 pounds, and how much salmon should be bought so that it meets customer demand on 90% of the days. So again, we can emphasize the importance of creating the right probability statements for these questions. A and B, obviously, we need to figure out what the probability is, whereas in C, you need to know, you are given the probability and you need to know what the value of that particular random variable is. And we do emphasize doing visualization, making graphs and stuff like that, and making sure that students can highlight what's given and what's not given. But once they have done that, we don't have to standardize it to Z and then look up the Z table, which is always rounded to 2 decimal places, get into these rounding issues. And as Guy's report suggests, that we should, whenever possible, we should stay away from these statistical tables. Next part, please. So once you have that, you can see that in Excel, again, we explain all the functions. It's just a question of plugging it in, and there comes the answer. And the same thing with R, where you just plug it in and you get the answer. I just want to say that, R is not an afterthought in this book. It's not something that's, only at the end of the book. It's in every chapter. And it's not just that the code, the line is given to you. It's everything's explained in great detail. I know some of you as instructors are nervous about introducing R or bringing R to your class. I was very nervous the first time I used it, which was 3 years ago, and my students were nervous. But now, since they see it in every chapter, by the time they go to regression and stuff, many of them stop using Excel, even though Excel is allowed throughout the book. So they just find R easier. Next slide, please. So this is a very quick example of, like what to do with regression, like all the details. We even provide details like sometimes R uses scientific notation. So if you just put in this options thing, then you'll see it the way you want to see it. That's the equation for multiple regression and how you view the output and how you make predictions with it. Next slide, please. And this is another example with forecasting. Again, in this particular case, we use a package, a built-in package called forecast. And once you're using the package, so this is, for example, you have quarterly data. So if you were to make forecasts, you have to first create dummy variables for each quarter in Excel. You don't have to do any of that in R. Once you have read the data as time series, R will know that it's quarterly data. So when you say, run this regression with trend and season, R knows what to do. These are the times when students say, hey, professor, R is so much easier than Excel. I hear it. I see nervous faces initially, and I see faces that tell me they're not going to use Excel again. Anyway, so that's my own experience. Next slide, please. So that's the fourth innovation. We always, the title of our book was always, with the colon, communicating with numbers. So storytelling was always important. We have just now focused even more on it, especially when you're making that indirect connection with analytics, that, takeaways, action. That's the end result. Just showing the mean is 33.29. Yeah, it's an interesting solving of the problem, but what does that mean? What does that mean to the business or to the organization or to a consumer? So what comes out of it? So that is what we are trying to emphasize. And because of this availability of data, we have updated our data, made them, most of them, a lot bigger than they were before. In addition, now we are using 3 big data sets that are used in various chapters of the book. These data sets are real data on college admission data. So there are 3 different colleges in this university, business, engineering, and arts, liberal arts. And so then they have to see, okay, if I want to study just business students, they have to filter out the data so that they only have business students. And again, get a taste of real world, not those 7 observations that we are used to seeing in earlier textbooks, find the mean of those 7 observations. And then we have similar thing with house price data. We have 11,000 data points. These are campus housing in, I think, 50 different campuses around the US. And then we also have tech sales reps data. Next slide, please. So there are 2 things which we do to emphasize communication. We try and do it throughout the chapter, each and every chapter in the solved examples. But 2 things that we do from step 1, and that's pretty much the step 1, which is called introductory case. Each and every chapter starts with an introductory case, where something that students may find interesting is shown to them. But then it's not just an interesting case which has no link to the rest of the chapter. In fact, you keep coming back to this introductory case and solving questions related to this introductory case. So this is a case where you have Fidelity Growth Fund and Fidelity Value Fund. And an investor is curious, should I be investing in growth fund or value fund? Again, it's a nice segue to understanding what the mean is, what is the typical return of each of these funds and what the risk is. Otherwise, when we used to do standard deviation, it's very difficult for students to relate to what standard deviation is. But now standard deviation is risk. So it's a risk of any particular fund is best picked up by standard deviation. Next slide, please. So through the chapter, we solve each and every question that was posed in the introductory case. But then we have this synopsis, what we call synopsis. It's a written report. It's a completely non-technical report. This is the report that you want to take to your clients. This is the report that you want to take to your managers. So this is absolutely real world. So my daughter works for, she's a data scientist. She works for a company and she tells me that she does all kinds of this difficult mathematical stuff. But what is shown to stakeholders is just a few pages takeaways. Sometimes she says even this is too much. It's even shorter than that. It's just some bullet points. That's what people want to see. So that's what we are trying to do with this synopsis. Next slide, please. So this is another example in the probability chapter. And Allison had mentioned earlier that we don't just give them the contingency table, we give them data. It's analytics is all about data. Everything has to be data informed. And so we are having this data about attendees that went to an open house at a gym, and their age could be, between 30 to 50, or it's over 50. There are different age groups there. And then some of those attendees end up buying membership. They actually enroll in the gym. Some of them enroll, some of them do not enroll. And now the manager wants to look at data like that and come up with some kind of strategy. What is that data-driven strategy? And so it's a probability chapter. We calculate those standard marginal probabilities, joint probabilities. We find out what the conditional probabilities are. Next slide, please. But the end result, again, is a synopsis. It's the takeaway. And the main takeaway, there are a bunch of things that come out, but the main takeaway is that most likely people who are between 30 to 50 years old are likely to enroll in this gym. So again, it's just simple data, simple analysis of probabilities. But now, if I'm the manager of that gym, I need to know that I need to go after those people who are between 30 and 50. And a similar thing, which is not here, we did with income. And again, we could say which income group people are more likely to enroll. Takeaways. Next slide, please. So the second innovation is that, so introductory cases at the beginning of each chapter. And the end of each chapter, whenever possible, we use big data. I showed you those 3 big data sets. So we use one of those big data sets and we try and, again, tell a story. Here, we are not teaching them how to solve these questions or anything. They have learned that in this sections, the relevant sections in the chapter. Here, we are asking them to have a report, which is a little longer than a synopsis. It's more like a page and a half to 2 pages of explaining. So this is an example where you had to summarize data for a pool of college students. Some of them are men, some of them are women, some of them are Asian, some of them are white. You have some of them come from this background, So it's like, how are you able to just use simple graphs to get a sense of what kind of an applicant pool this particular college has, and then you do a report. So what you're seeing on this slide is just a portion of that report. This is another example, which is again similar. It's big data. So this is about house price. So we took an example of University of Iowa, which is in Ames. And so we have data on the square footage, the rental information, how many bedrooms, how many baths, is it a relatively newer house, is it an old house, and then trying to analyze rent. So that's something that students can relate to. And then similarly, or a price. So this is also from the point of view of a real estate company that wants to buy this property as an investment property. So again, you come up with a story, and we came up with some interesting results. This is real data, and we came up with some interesting result about the premium that's attached to houses which are relatively new. And that's kind of, all the 4 innovations. And as we said, both Allison and I said earlier in our part of the presentation, it's all related to how do you make it more business analytic-y, if I don't know if that's a word, and also be consistent with what GAIS says. That's American Statistical Institute, that let the computer do the computations and let the student try and come up with some takeaways. So we're going to stop here now and would be happy to take questions.
Steve, I had a private question asking whether you or Allison use R or whether you use Excel or both. And do you use it with both?
I can start.
Sure.
I use actually both. And because of the pandemic, it actually led me to that a lot faster. So I am very much away from the chug and plug that how I at times used to teach statistics to now following what Geis is suggesting. So I actually have my students now, first time I've ever done this, bring their laptops to class. And on day one, we start with Excel and getting everybody up to speed with R. So day one, we're good to go. Everyone's good to go. No one has an issue. And I feel like they know they need to have these skills to succeed once they graduate. So I am getting zero pushback from my students.
I do it slightly differently. So the first part of my course, I will tell them that Excel and R, they're both very important, and they are free to use whichever they feel more comfortable with. But I also tell them that for the first few weeks, my lectures will focus more on Excel. And so when I'm solving, binomial or Poisson or normal distribution questions, I use Excel, but I say I would encourage you to read R on your own. But the minute I move to regression, I switch to R. Then I also show them a few calculations in Excel. And then some of the students, as I had said in my presentation, tell me, hey, professor, if R was so easy, why didn't we start from R on day one? So maybe I'll move the way Allison does it, to use both from day one.
What is your answer to that, Sanjeev?
Sorry?
What's your answer to that question?
I can.
I said, when they ask you, why didn't we just start with R?
So I told them I'm learning.
We'll get there. Awesome. So another question, how has COVID changed your teaching method or tools, etc., or has it?
Again, I never had them bring their laptops to class. But now I find it very much, no one's falling asleep, right? Everybody's trying to keep up with me. The whole experiential learning, I feel that I've finally gotten that into a statistics class. I had always used Connect in terms of homework assignments, and I have continued doing that, and they like that repetitive, bringing the laptop to class, solve problems in class, go home, do it for homework. So I feel like it's been really good. Like that's been my really good COVID story, not the Zoom.
Your COVID takeaway?
Yeah, my good COVID takeaway.
Yeah, I also actually had a COVID takeaway. I always had mixed feelings about online learning. I wasn't sure. I had done it once, but COVID forced me to develop certain things, which was completely virtual last year. And so I have become a fan now. So this academic year, we are in a in-person mode. So, but I have flipped my classroom. So I actually do portion virtually. And the advantage is students keep telling me that, especially with difficult topics, they can keep rewinding and listening to certain things over and over again. So when I meet them, that time I take on their questions and I make them do problems using Excel and R in class while I'm watching them. I think this might be something I'm going to continue doing now. I mean, that's a great positive that I learned myself from COVID.
Love it. All right, we have just 5 minutes left. There was a question that sort of got back to the panel earlier, and the question was whether you both teach business analytics as well, and sort of where that fits in the curriculum, and sort of does the BStat tie into the analytics book?
Yeah.
Well, so I teach, we still call our class applied statistics.
Okay.
However, I'm bringing a lot of, I don't think they're too distinct, or what we might say in stats, mutually exclusive topics, business analytics and business statistics. So I'm bringing in the visualization, I'm bringing in the subsetted means, I'm doing, the pivot tables to the contingency tables. So I teach a, introductory statistics class, and we're still teaching econometrics. I am in the economics department, and I am using the latter chapters of our business statistics and business analytics textbooks in my econometrics class, because largely, because of how we cover the material with incorporating business analytics, but also because of the Connect product.
Yeah, I'm doing something similar, making the course a lot more, with a lot more focus on analytics, not getting into data mining topics like, KNN, I think for which the other book might be more relevant. But I do, even in my basic course, I do spend a lot of time on logistic regression, and then all the performance measures, whether it's accuracy or sensitivity or specificity. So that aspect definitely is something I took on in the last few years. I didn't do that before.
All right. Fantastic. I think that is it for questions. Unless you see any others, Eric. I want to thank you both for a fantastic presentation. It was really, really interesting, and I loved seeing all the tie-in to the employability session that we had earlier, and what you do in the book. I feel like is so similar to that sort of real life experience that
Brian
talked about. So thank you so much for the presentation.
Okay, thank you.
Sanjeev.